Number 21, let f be the function given by f of x equals 2x e to the x. The graph of f is concave down when what? So concavity comes from the second derivative. So we need to take the first derivative first, obviously. This function is 2x times e to the x. So we will have to use the product rule here. The derivative of 2x is 2 times e to the x plus 2x times the derivative of e to the x, which is e to the x. Let's simplify this. We can factor out 2e to the x. That leaves us with 1 plus x. When I was working this out the first time, I went ahead and took the second derivative straight from here. If you did that, the derivative of 2e to the x, this is not a product rule because there's not an x with this 2. It's just a constant times a function. In that case, the constant stays, and we take the derivative of e to the x, which is e to the x, plus we just did this exact same thing to get all of this. So product rule on 2x e to the x is 2e to the x plus 2x e to the x. Doing it this way, you will get the same answer. Let me do it that way just in case you worked it that way. This is a product rule. The derivative of 2e to the x is 2e to the x times 1 plus x plus 2e to the x, oops, times the derivative of 1 plus x, which is just 1. So I'm not even going to write that. So to find concavity, we're going to set the second derivative equal to 0 to get our points, our inflection points. Just looking at the two ways that I did it, I think looking at this one is going to be a lot easier to set equal to 0. So that's what I'm going to do. Oh, first of all, we combine some like terms here. 2e to the x plus 2e to the x is 4e to the x plus 2x e to the x, and we're setting that equal to 0. Looking at what these two terms have in common, we can factor out a 2e to the x. That leaves us with 2 plus x. Two e to the x will never be 0 because no matter what we put as our exponent here, you can't get 0. So we really don't have to worry about 2e to the x. We really just need to look at 2 plus x equals 0, which would give us an x value of -2. So that is our inflection point. It's the only number that we need to plot on our number line. We need to test a number on either side into the second derivative. Let's see. We try -3. I'm going to plug it into this line, I think would be easiest. We get 4e to the -3 plus 2 times -3 e to the -3. We end up with a negative value. On the right side of -2, obviously 0 is going to be easiest. 4e to the 0 plus 2 times 0 e to the 0, +4. So we get a negative on the left and a positive on the right. Question is asking where it is concave down. That is where the second derivative is negative. So on the interval from -infinity to -2, which on your review is written as x is less than -2.